Good afternoon, everyone. I'm Abhay from EDS Technologies. First of all, I would like to thank everyone for taking your time out and joining this webinar, which we have titled as Ensuring Advanced Monitoring, CSR Reporting and Compliance for the Mining Industry with GIS Solutions. So before handing it over to our guest speaker and our technical speakers, I would like to begin the webinar by giving a short introduction about our company, EDS Technologies. So Yeah, EDS Technologies was incorporated in 1994 to focus on providing PLM solutions, implementation, and support. We are the largest technology solutions provider in India and also a partner to Esri. We have served more than 2,000 customers across India and operate in 10 locations, with our headquarters being at Bangalore. We also have strategic partnerships with world leaders like Dassault Systems, EOS for additive manufacturing requirements, Human Solutions for ergonomic solutions, uh, Technia for ensuring product data quality. For military simulation and training needs of aerospace and defense industry, we have partnered with MAC for visual simulation solutions. We also have a strategic partnership with Synopsys for EDA solutions. We have a dedicated sales, support, marketing, and customer satisfaction teams to address our customers' PLM business and support requirements. In today's webinar, we are joined by Mr. Susanta Maharana from ArcelorMittal Nippon Steel India and our technical speakers, Mr. Yogesh and Mr. Rohit. So our guest speaker for today is Mr. Susanta Maharana. He has more than 13 years of experience as a geologist in different iron and manganese ore. He was involved in mineral exploration, mine planning, and quality control of different iron and manganese ore. He has done his MSc in applied geology from College of Engineering, Guindy, Anna University in Chennai. Currently, he is working as Senior Lead Geology and QC in ArcelorMittal Nippon Steel India. We thank you, sir, for accepting our invite to be a guest speaker in this webinar. Second, we move on to Mr. Yogesh. Mr. Yogesh is a seasoned professional with more than 14 years of experience in the geospatial industry. He holds a master's degree in remote sensing and GIS. He has a diverse experience and has worked in multifaceted roles across central universities, research organizations, NGOs, and the private sector. He is the recipient of the Nehru Grimson Fellowship Award by the President of Iceland. Currently, he is leading a team at EDS Technologies, specializing in GIS technology solutions. He is proficient in offering tailored GIS solutions to various businesses, resolving their complex challenges through innovative approaches. Our third speaker is Mr. Rohit. He has more than 6 years of experience in designing, developing, and implementing GIS systems and databases to access and store geospatial data. He has worked as a remote sensing expert in public and private organizations in different projects, ranging from smart cities to precision farming. He has done his BTech in civil engineering from Manipal University, Jaipur, and MTech in geomatics from CPT University in Ahmedabad. Over to you, Yogi.
Thank you, Abhay. Thank you very much. Warm welcome to all for today's webinar. And our special thanks to Sushanta sir for accepting our invitation to be a key speaker of this particular webinar. And actually, Sushanta sir is using this GIS Esri technology for quite some time. He has extensive experience, and I know that our audience is also eager to learn more about his expertise in GIS. So further ado, I want to know, Sushanta sir, you are using this solution for quite some time. Exactly how you use this solution and how it is benefiting you.
Thank you again for the brief introduction. Actually, I am using this GIS software from last 1 year, more than 1 year, I think. So it is quite helpful for our day-to-day activity related to different map preparation and land use map preparation. Basically, mostly it is using for the georeferencing of the different cadastral image and topo sheets, so that we can easily georeferencing, and for the digitization of the different land use and area calculation. Like in the topo sheet, we have different land use like forest, non-forest, village, roads, and different. different areas. So that can be, we can easily calculate it in different unit also, like area in hectare, area in meter square, area in square feet. So, and the digitized map can be easily exported into the KML platform, so that it is usually you can visualize the location in global view. So, and in addition to this, we are using this map, this platform for the exporting of the, for a particular lease. If you have a different lease boundary coordinate, so that lease boundary coordinate can be brought into the GIS platform, and from that platform we can join the lease boundary point and creating the boundary of the lease area, and after that we can create the area of the lease which we have granted. And after that, that lease area and the save file lease boundary, that everything can be put into the KML platform, and the save file also we can save it for the future reference also. And in addition to this, that in day-to-day activity, earlier we are using the AutoCAD file. So that AutoCAD file you can also export into the ArcGIS platform, and the different layers in the ArcGIS, the different layers in the AutoCAD, that can be exported into the shape file, and that shape file can be exported to the KML platform. So it is a very good for the, because most of the files we are having a digitable file, but here we can convert the entire digitable file into a shape file, and subsequently that shape file can also be converted into the KML file also. And also in our day-to-day activities, we are using for preparation of the different maps related to our IBM, or any map related to the forest department. Like in few times in IBM we have the doing submission of the mining plan also, we have the different types of the maps we need to submit. And now presently the government is, Minister of Mines is asking all the files need to be in the save file format. So it's very easy to put it in the save file format, and we are submitting the data. And also the preparation of the key plan by considering the lease area and by considering the topographic map. So we are preparing the buffer map of 50 meter, it's 500 meter, 1 kilometer, 10 kilometer, whatever the map we need, that we can prepare. Presently we are preparing that maps. So like this, from the last 1 year, I am using these types of, so AutoCAD is helping me to prepare these types of the map and to solve these activities. Most important thing here, I have seen that in ArcGIS, if you fix the save files and you calculate the area, it is saved for ever. And at any point of time, if you open that file and you open the attribute table, all the different head wise and different location wise, the area will be saved, and it will be easy to track for the user reference also. And also the geo-referencing is also very much available. But before geo-referencing, everybody should know that in which coordinate system you are working, whether it is in WGS84 or different coordinate system, whether you are using the raw data in degree meter second or it is in UTM format. Then only that area calculation and everything can be possible. Otherwise, if it in you are using a coordinate system, but you are set the screen in a different coordinate system, then it will be difficult for the system to calculate the areas. Otherwise, this is present we are doing, but in future also, if any advanced technology, or if anything new we can do by using this ArcGIS platform. जैसे कि हम लोग आरजीएस को लेके कैसे हम लोग जैसे कि मंथली हम लोग ड्रोन इमेज का डाटा लेते हैं. So drone image data, how it will be helpful for us. And presently we are not using ArcGIS for interpretation of the drone image maps. So is it useful? Can you do the interpretation in ArcGIS by using drone image map? If it is possible, then how it is possible? उसका क्या process है, क्या है, that I want to know. And one more thing is that if we are preparing one shape file of a particular area, or we are putting one boundary, if we have the boundary coordinate, हम लोग वो area को plot कर दिया, लेकिन उसका ArcGIS का backdrop में ही उसका वो updated सैटेलाइट इमेज आ सकता है कि जो लेटेस्ट अपडेट सैटेलाइट इमेज है हम लोग जैसे KML में कन्वर्ट करते हैं, बट विदाउट कन्वर्टिंग द KML ओनली फॉर द विजुअलाइजेशन, वेदर इट इज पॉसिबल टू बी दैट अपडेटेड सैटेलाइट इमेज इन द बैकड्रॉप, वो एक मतलब पॉसिबल हो सकता है कि वो आप थोड़ा डिस्क्राइब करने से बेटर रहेगा। और एक चीज है कि हाइड्रोजियोलॉजी रिलेटेड, जैसे कि हम लोग का लीज एरिया ऑन्डुलेशन टेरेन में है एंड मोस्ट ऑफ द लीज एरिया इज इन द फॉरेस्ट एरिया एंड इन हिली एरिया, so it is most prone for the rain and surface water runoff management. So most of the leases we are facing that surface water runoff management. So to visualize the surface water runoff before rain by using the 2D map, it is very difficult. There are lots of survey work we need to do. So can we have a visualization or interpretation or any map by using this ArcGIS platform? तो सरफेस वाटर मैनेजमेंट की कहाँ से वाटर फ्लो होगा, कौन सा डायरेक्शन में जाएगा, कहाँ पे एक्यूमुलेट होगा. So if it is possible by using this platform, then it will be also helpful for us. So likewise, it is a very good platform, I think, in for my knowledge, because last 1 year से मैं भी जो भी यूज कर रहा हूँ वो मेरे को बहुत हेल्पफुल हो रहा है. जैसे कि एक ही फाइल में हम लोग नंबर ऑफ लीजेस का डाटा भी एक्यूमुलेट करके रख सकते हैं, उसको कोरिलेट कर सकते हैं, और उसको KML फाइल में कन्वर्ट करने के बाद भी अगर एक लीज को आप देख रहे हैं तो एक आइडिया मिलेगा, लेकिन उसको रेफरेंस में डिफरेंट लीजेस में क्या है, क्या कितना डिस्टेंस में है, क्या है, वो जियोलॉजिकली भी बहुत सपोर्ट करता है हम लोग को. और ऑल्सो हम लोग अभी मंथली हम लोग जियोलॉजिकल मैप जैसे अपडेट करते हैं, तो उस हिसाब से हम लोग का डिफरेंट लिथो यूनिट का सरफेस जियोलॉजिकल मैप से ड्रा करके लेते हैं, देन विल importing into the ArcGIS platform. So it is very easy for us to draw the surface geological map, and regularly we are preparing the updated surface geological plan. So this is all from my side.
Yes, sir. Actually, yes, sir. You said about like you use this solution for creating various types of maps or creating the lease boundaries. So, what kind of raw data generally you use? Means what data you get from maybe from the field or from different sources? What is that format and how you use it for further analysis? Like you digitize and create shape boundaries.
Actually, raw data, the lease boundary coordinate first you have to get either in degree minute second or in UTM coordinate. But actually, one problem I have faced here, in the degree minute second file, we cannot import into the ArcGIS platform.
Okay.
Only the degree decimal degree only we can import into the platform. If it is degree minute second coordinate is available, then that we have to convert into the degree decimal first. And then first we have to put the easting, then northing, then the identification mark of that particular, like a boundary, pillar number, yeah, location number, or anything for each and every point. And but if it is in UTM coordinate, then directly easting, northing, and the location of the identified location, pillar ID or something that we can put, and that we have to convert into the CSV format first. That CSV format we can import into the ArcGIS platform. And after that also, that once you import into the ArcGIS platform, that we need to convert into layer file, that is a save file. So once you convert that point file into the save file, so for the when we go to use for the next time, it will automatically convert into that coordinate system.
Okay.
So then उसके बाद हम लोग डिफरेंट करके सेव फाइल, एक बाउंड्री लाइन का एक सेव फाइल लेते हैं, सेव फाइल लेके इसको क्लोज बाउंड्री बनाते हैं. बनाने के बाद उसका फर्दर जो एरिया कैलकुलेशन करना है या कुछ में ओवरलैप करना है, उसको फिर बाद में करते हैं.
Sir, do you use any maps like topographic maps or something like that also for this analysis, or you generally just get the coordinates only from field?
Sorry, I'm not getting you. Topographic map means?
Topographic map or topo sheets. So do you use that kind of maps also?
yes, टोपो सीट जैसे मैं बताया अभी कि टोपो सीट को भी हम लोग पहले तो टोपो सीट वो तो अननोन को एक जेपीजी फाइल रहता है, तो उसका कोऑर्डिनेट सिस्टम इज अननोन, ओनली कोऑर्डिनेट सिस्टम उसके अंदर में लिखा रहता है. तो फर्स्ट यू नीड टू ब्रिंग दैट जेपीजी फाइल इनटू द कोऑर्डिनेट सिस्टम. कोऑर्डिनेट सिस्टम में लाने के लिए हम लोग पहले स्क्रीन को उसका कोऑर्डिनेट सिस्टम में सेट करते हैं कि WS84 में, क्योंकि जनरली टोपो सीट डिग्री मिनट सेकंड में रहता है, तो WS84 में उसको सेट करना रहता है. देन उसका मिनिमम 4 पॉइंट को लेके 4 पॉइंट का एक्चुअल कोऑर्डिनेट जो है, 4 पॉइंट का कोऑर्डिनेट लेने के बाद वो जियो रेफरेंसिंग होके वो मैप सेट कोऑर्डिनेट सिस्टम में आ जाता है। देन उसको टीप फाइल में फिर उसको कन्वर्ट करते हैं। तो टीप फाइल में वंस कन्वर्ट हो जाने के बाद नेक्स्ट टाइम आप जब उसको ड्रैग एंड ड्रॉप करेंगे तो वो ऑटोमेटिकली कोऑर्डिनेट सिस्टम में आ जाएगा। उसके ऊपर में फिर आप अपना लीज बाउंड्री का कोऑर्डिनेट या जो भी उसको ओवरलैप कर रहे हैं तो उसको रेफरेंस ले सकते हैं कि टॉपोसिट में हम लोग कहाँ पे है, एग्जैक्ट लोकेशन क्या है, और नियर बाई कहीं नाला जा रहा है, कहीं फॉरेस्ट एरिया है कि क्या विलेजेस है, क्या है, उसको ऊपर इंटरप्रिटेशन करके फर्दर डिसीजन मैनेजमेंट को जो भी रिक्वायरमेंट है रिलेटेड टू दिस लैंड यूज ऑफ द नियर बाई एरिया तो हम लोग इजिली ले सकते हैं।
Okay. So actually, a degree minute second actually RGIS do accept, but I think you might be not knowing this. So maybe after after our meeting and all, we'll explain you how you can actually use this degree minute second as well. So sir, do you find this? Yes, sir. Yes, sir.
हाँ यस, क्योंकि मैं ट्राई किया था कि डिग्री मिनट सेकंड से भी कन्वर्ट करने के लिए, लेकिन वो नहीं हुआ, बहुत डेसिमल डिग्री में हो रहा था। सो आई थॉट दैट इट हैज नॉट बीन इन द प्लेटफॉर्म।
Yes, sir. Yes, sir. So we'll do that also later. So do you find this solution useful? Like, has it improved your efficiency, or are there any activities which are which was not possible before you started working? You started doing that after using this software. Are there any like required data sets or processes which you able to do using only this solution?
एक्चुअली ये यूज करने के बाद मोस्ट हम लोग को ज्यादा जो KML फाइल में कन्वर्सन जो होता है वो बहुत इजी रहता है, एंड दैट KML फाइल आल्सो यू कैन ब्रिंग इट इन योर हैंडसेट आल्सो, एंड दैट KML फाइल यू कैन ओपन इन योर मोबाइल आल्सो। तो वो होने से आपका KML फाइल मोबाइल के साथ आप कौन सा लोकेशन में, कौन सा लीज एरिया में है, कहाँ पे है, मैपिंग करने के टाइम में जानने के लिए भी एक रॉ डाटा के हिसाब से अब तो एक्यूरेसी के लिए आप GPS या अदर फील्ड प्रिकॉशन हम लोग लेंगे, बट कौन सा लोकेशन में क्या है वो इजीली थोड़ा इजी रहता है उसको ये करने के लिए। और बाकी जैसे कि डिफरेंट प्लेटफॉर्म में जो पहले यूज कर रहा था, जैसे कि हम लोग कुछ एक पर्टिकुलर लीज का या डिफरेंट लैंड यूज का जब एरिया निकालते हैं तो हम लोग वो डिफरेंट कमांड से हम लोग एरिया निकालते थे, लेकिन वो प्लेटफॉर्म क्लोज होने के बाद जो भी हम लोग का एक्सरसाइज था वो मैप तो सेव हो गया, लेकिन डिफरेंट एक्टिविटी जैसे कि एरिया का क्या है वो सेव नहीं रहता था। लेकिन इसमें जो एट्रीब्यूट टेबल का एक रहता है, वो एट्रीब्यूट टेबल में एक बार आपको एक्सरसाइज करने से वो सेव हो गया, देन उसका आपको डिफरेंट यूनिट्स में जो कन्वर्ट करके ले सकते हैं। आप वही सेम एट्रीब्यूट टेबल में 3-4 यूनिट में ले सकते हैं, 1 स्क्वायर फीट में ले लिए, 1 मीटर स्क्वायर में ले लिए, 1 स्क्वायर किलोमीटर में ले लिए। तो कभी कभी डिफरेंट यूनिट्स का भी रिक्वायरमेंट रहता है, वो एक इजी हुआ मेरे लिए, बेनिफिट हुआ फ्रॉम लास्ट 1 ईयर जो भी हम लोग यूज कर रहे हैं। और जैसे कि लास्ट ईयर हम लोग भी जो एनुअल रिटर्न हम लोग सबमिट किए थे IBM का, उसमें एक रिक्वायरमेंट था कि लैंड यूज मैप, अपडेटेड लैंड यूज मैप, एंड लैंड यूज मैप शुड बी टैली विथ योर whatever the data you are submitting in the annual return, and for the supporting of the annual return you need to submit a save file and KML file also. So that land use map also I have prepared by using this RGIS platform, और वो बहुत हेल्पफुल भी हुआ हम लोगों को।
Okay, okay. Thank you very much for that, sir. So we are happy that you are using this solution quite well, and you are finding it also very efficient, and you can do a lot of different types of work also, and you like save a lot of time. You don't need to do repetitive task again and again. Once you save the files, you can use that same file again, and you can convert the different units also. So I think we can now go to Rohit, and he will go through this technical presentation as well. So over to you, Rohit.
Thank you, Agyas, and thank you, Sushanta sir. Industry inputs always very helpful for us to providing suitable solutions to the industry. So today presentations agenda will be going to deliver into 5 parts. So we're going to start with the small introductions, the GIS and how GIS can help in mining, and then we move to the advanced monitoring and compliance systems, how GIS help in there. Then we also going to discuss about the hydrological monitoring, hydrological modeling, and how GIS going to help you for mine sustainability in the terms of hydrological monitoring. At the end of the presentation, we also going to discuss about the CSR reporting, the corporate social responsibility, how GIS going to help the GIS mining companies and the agencies who are taking care of CSR activities, how they can use GIS to enhance those capabilities. You guys going to discuss that at the end. We are going to have this Q&A session. So if you have any questions during the presentation, you can drop on the chat box, and at the end we're going to take those questions. So going forward, we're going to start with our presentation about the introduction and GIS for the mining. So GIS, like you all know, it's a geographical information system, which refer as a system to design, capture, store, analyze, manage, and present spatial data. So these are the core of GIS. We capture, we store, we analyze, manage, and present the data. So in capture data, you can capture any type of data, like drawing files, which we prepared in AutoCAD, like Sushanta sir was discussing. You can prepare those drawing file in GIS. You can digitize maps, and you can capture as a vector data. You can capture the images, which we call raster images, from any flying platforms, drones, satellites. You can capture those images. If you have these scan maps, scan topo sheets, like we are discussing, that also this system will take as a raster file. You can take it, reference it, and digitize it over it. You can prepare your entire land management system using the scan revenue sheets. So you can capture data in that way. You can store, you can organize the those data, acquired data in structured manner, and you can use those database. You can analyze. So this is a misconceptions I found in the industries or in a student fraternity, like GIS is a digital cartography. GIS is not all about the digital cartography until yes, maps are the primary output of GIS, but it's not all. Once you getting the data which can produce your maps, but you can do a lots of analysis on those data sets. In ArcGIS ecosystem, you can find thousands number of tools for in each fields, and you can run those tools, those algorithm to interpret the spatial pattern, relationship, and trend between the spatial data sets. Spatial data set basically data with the location attached. You can manage those data sets. You can manage spatial data, ensuring those data integrity, security, and accessibility. You can share your data, your mining data, your workforce data. You can share those within your ecosystem, within your company profile, profiles or company structure, and you can manage the security also within the GIS framework. You can also manage who can access that data. You can present your data in an interactive manner. You can present your data in interactive maps, like web maps. Anyone can open your maps, zoom it to a certain level. If you allow them, he can do a certain analysis on those data sets. You can prepare not only database, simple database, land management system database. You can share those database online and with a credential, and anyone can access it. So these type of capabilities you can get in GIS. So GIS for mining is the integration of GIS technology in mining industry, enhance decision making. How it's optimize the operations, promote sustainability, and responsible for mining practices. So in operations, starting from the mapping till the reclamation, in all activities, GIS is going to help you. Okay, in explorations, mineral explorations, you can use our satellite images, drone images. Based on the their data sets, you can do the explorations, you can map them, you can evaluate the mining condition. We're going to discuss in detail the security compliances, how GIS or ArcGIS is going to help you in the security compliances, land management, to prepare a digital land management database, like Sushanta sir was discussing. You can prepare those, you can share within your system. Environmental impact assessment reporting, or any like water resource reporting, preparing those kind of reports for the stakeholders, for the public, for the government clearance. Those type of report also you can prepare using ArcGIS. So key component of mining by using ArcGIS or the GIS in the broad terms. So spatial analysis play a crucial role in mining operations. It's about a variety of technique and technology aim to understand and optimize the spatial aspect and mineral exploration. Okay, so in my mapping and planning, ArcGIS commonly integrate the and analysis of the various spatial database. For the mapping, we collect data, we collect from the ground. We send our server to ground. They collect DGPS data. They collect GCP data. Drone survey is also a land data collections, simply data collections. We can collect those data from different sources. It could be a mobile application. You can collect those data. You can integrate those data, all those data into one system. That is GIS. Okay. If you have a simple tabular data is collected on the tabular manner, that also can be integrated to your database. Okay. If you have a database in tabular manner regarding the boreholes information, okay, if you able to put the exact location of those boreholes tabular data, you can open on the map and you can visualize where those boreholes was digged. Okay, so GIS definitely going to help in there for the mapping and planning. The second is resource estimation. So how we do resource estimations in mining? Surface resource estimations. We do basically borehole survey. We collect the samples from the ground and we run interpolations on the system. So ArcGIS provide you all interpolation mathematical model in it. If you need statistical techniques like kriging, inverse distance weighted interpolations, Gaussian simulations, all those interpolation models are within ArcGIS. So if you have the borehole data, you can put into ArcGIS. You can run any interpolation models. Based on that, you can visualize or interpolate 3D ore body deposited subsurface or over surface. So these type of capabilities you can also get from GIS. Okay, in environmental impact assessment reporting. So GIS used to analyze factors such as land use, hydrology, biodiversity, identifying the sensitive area, not in the mining zone but surrounding of the mining zone. It's very important. Like government or the bodies need those type of data from you. They want to know, because of your mining activity, what happening surrounding of your mines. Okay, is there, if there is any sensitive mining sensitive biodiversity area surrounding your mining. Okay, there is any particular lake or particular water body, okay, which you don't want to harm, so you can plan your activity in a way so that your activity, your mining operations activity, not going to harm those biodiversity area or those critical infrastructures. Okay, for that you can use ArcGIS. Okay, if someone is questioning, you can present those reports like, we are doing mining since 10 years, and since 10 years there is no land use or there is no green loss in that area. If someone is claiming like this percentage of green loss has done due to this mining activity, you have those satellite images, you have those reports, you can present and tell, you know, there is no loss in last 10 years. Okay, if there is any loss, we produce so much of green field in this particular area, so we are balancing that. So in this manner you can prepare report to back your claims. Reclamation activity also, GIS can help you. GIS help for sustainable analysis to identify suitable land use for reclamation, spatially explicit models to simulate long-term impact of reclamation activities. Second part is to advanced monitoring and compliances. So advanced monitoring and compliances in mining require sophisticated tools and technology to track and manage various aspects of operations, including environmental impact, safety compliance, and regulatory requirements. So in advanced monitoring and compliances can be bifurcated into 6 parts. For our understanding, we bifurcated into 6 parts, starting from the environmental monitoring, land reclamation monitoring, water resource management, and also regulatory reporting and compliances. Okay, so GIS offer powerful capabilities to monitor and ensuring compliances in mining activity, for all 6. By leveraging GIS technology, mining companies can enhance environmental stewardship and promote safety and sustainability. It's also build the trust with the stakeholders, not only for the stakeholders, but also the human habitat areas living surrounding your mining activity, or with the also with the government and the other agencies. How it's going to help you for the environmental monitoring? We already discussed in the brief, but we're going to discuss in detail in this slide. So GIS is going to help you to map or monitor environmental parameters. We have 4 environmental parameters which we listed here. air quality, water quality, soil contaminations, and habitat integrity. Human habitat integrity surround not only for the mining area but surrounding the mining area. So GIS used to monitor and analyze environmental parameters such as air quality, water quality, soil contamination, and habitat integrity. Integration of GIS from remote sensing. Remote sensing means your drone data, satellite data. Satellite database we also have, so you can use our satellite database. We have high resolution satellite images of last 10 years, those repository with us, so you can use it free of cost if you are our customer. So by integrating remote sensing data, field measurement, environmental sensors, if you install those IoT sensor on the ground, those sensors can push their data. You can visualize their data in a real time. So air quality you can visualize real time. Okay, you can find those maps on the web, where government is publishing PM 2.5, PM 10 values in a live stream manner, and you can visualize the what is the air quality index in Noida, what is the air quality index in Pune. So those data you can get. Okay, so if you have the IoT sensor installed certain location of your mining area, you can also have the air quality, moisture level, those kind of data, and you can integrate those data in GIS. And GIS enable you and us to visualize spatial pattern of environmental impact and assess the compliances with regulatory standard. Okay, so if we integrating all this database on a system and we know what are the regulatory standards, we can put those regulatory standards on these parameters, and we can see which area we are failing. Okay, which area we are failing, and on which area we have to do something, and which steps if we take today, tomorrow it going to save us some cost. Okay, if some penalty is going to impose on us because we are failing in certain area due to some environmental impact, we can save those money. Environmental based in GIS based environmental monitoring system can generate and start notifications. It can send you notifications also. In land reclamation monitoring, GIS definitely going to help you. You can monitor and track reclamation activities in the mined area, or the area you're going to mine. GIS based monitoring system enable company to track change in land cover, land use, which some of our customers are already doing. They additionally, you can also if you want to see what are the land use are happening in last 10 years, suppose you get the allotment of some mining lease today and it got stuck in illegal. In last 5 years, people done much of the constructions which payment you don't have to pay. You can see like in last 5 years how much constructions are happened, or what land use changed in last 5 years, which I'm not supposed to pay for that. So those kind of analysis, those kind of study we can do. Safety compliances and monitoring. So safety, GIS based safety monitoring system, it allows you to identify risk area, high risk area, track compliances with the safety protocol. You can integrate your whatever the safety protocol with this system, and you can regulate it. Facilitate incident reporting and investigations. GIS use map to analyze safety related data such as incident reporting, inspections record, and hazard assessment. Okay, in detail, if you want to see if there is any safety issue related to environment, safety related to operations, you can map those, and a system can be built where those parameters will be infused, and alert can be generated when those systems are going to fail, when those parameters going to be crossed. In this part, I'm going to discuss in detail about the volume and monitoring activity. So stockpile volume calculations, we all know we can do using the DSM, the digital surface model. But while doing our drone survey, we also collect the point cloud data. That point cloud data is very important. We can use the point cloud data, like in this image, you can see we use EBK interpolation technique to visualize our mines in 3D. Okay, by visualizing mines in 3D, I can produce slope layer. And if I put the parameters like safety parameters within the slope layers, I can delineate the fault on the steep slopes. I can delineate the fault or the dangerous haul road conditions for the mine transportation. I can do the cut fill analysis, cut fill planning. I can also do the landslide risk assessment. Not only landslide risk assessment, bench filling you can also do. Okay, if I have this type of data, simply I have to put the parameters. So GIS play a crucial role in hydrological monitoring for mine sustainability by providing tools and capability to assess, manage, and protect water resources associated with the mining operations, not for the only for the mining area, but surrounding of the mining area also. So hydrological monitoring, GIS in hydrological monitoring in mines can be segregated in 6 parts, 6 components: water resource mapping, hydrological modeling, water quality modeling, stormwater management, water balance analysis, and regulatory compliance and monitoring for the water and surrounding the mining area. Okay, so GIS instrumental in hydrological monitoring in mining operations provide tools and capability to access, manage, and protect water resources. So water resource mapping. Water resource mapping GIS enable companies to map and inventory water resources, including surface water bodies, ground aquifer, and water courses within or surrounding the water area. By integrating various geospatial databases such as topography, land cover, hydrological network, GIS help create comprehensive maps that identify water sources, flow path, and recharge area. GIS water resources system, if you want to build, it contains data management, the part of the data management, where we create raster or vector GIS relationship or representations of the landscape, build the environment, and water resource analysis. Integrations of data systems. So we integrate the raster. The raster part is the ortho image, or it could be the DSM. The vector or the tabular data. Tabular data could be if the IoT systems are installed, or there is already some water bodies are there where which depth you calculated in a tabular manner, so you can use that also. And the vector layer, definitely if you delineate or you digitize the water bodies, so by integrating those systems we can prepare a better water resource mapping and analysis. Definitely by doing analysis you can identify things, determine the flow directions, flow accumulations, flow direction, characterizing of watershed, identification of watershed area, floodplain. Those type of analysis we can do if we integrate our database like DSM or DM, which we prepared using our drone data, the vector data which we already have, like the existing water bodies, or if we have any tabular data like rainfall of last year or last 6 months or 6 year of rainfall. By these tabular data, if we able to integrate it, we can definitely going to have an idea like at what level, what water level, which part of our mine is going to be flooded, and by doing what activity or which part of our mine is going to be flooded. Hydrological modeling. So these are very typical work in GIS. Like anyone who is working with the GIS, they already know about it. So you can do it. And on the screen, the GIF you can see it is a simulation. So water simulations you can also do. Not only you can identify the water flow directions, you can also identify if the flow direction increase, the flow accumulations increase, the runoff increase, which area going to be water submerged. So this type of analysis you can do in hydrological modeling. Okay, so it allows you to simulate analysis, water flow, runoff, groundwater interactions within the mining area. Okay, and GIS facilitate to integration of spatial data. We already discussed with hydrological modeling. You can prepare those hydrological modeling, and not only that, you have to code it or anything. Those tools are already inbuilt in ArcGIS. You can directly use it for the regulatory compliances. Okay, so GIS support monitoring and compliances with water related regulation, permit applications, and water operations. GIS based regulatory compliance system enable company to track, report in this image you can see track and report the water usage, discharge, water quality parameters. Those parameters could be anything based on your requirement. You can put all those parameters, and it allow you to give the regulatory requirement related water management system. And GIS also help to ensure compliances with environmental permit, stakeholder engagement and regulatory compliances. Okay, so GIS supports stakeholder engagement and communication by providing interactive maps and visualization of hydrological data and informations. Mining company use GIS to communicate with the regulators, local communities, other stakeholders about water management practices, environmental impact, and mitigations measures. GIS-based stakeholder engagement tool promote transparency, collaborations, and informed decision making. Next part is CSR reporting and regulatory adherence. So Yogesh is going to give you brief about it. Yogesh, over to you.
Yes, thanks Rohit. So good thing about the ECD solution is this ECD solution, the same solution can be used for different purposes also. We saw that for core mining activities, how GIS ECD solution will is useful. But other than that, even for HR or CSR purpose also, we can use this particular solution. To give some example, like different activities, like for example, priority areas. So to map different priority areas where you need to do the CSR activity, those priority areas mapping you can do using this particular solution. And you can actually understand the different environmental conditions, like what is the current biodiversity in that area, how much is the forest cover, what is the water availability. So that kind of entire analysis you can do, and accordingly you can plan your various CSR activities in that area. And you can use this for interactive mapping as well, like you can map, as I mentioned, various layers you can map using the GIS solution, and you can create interactive maps or interactive charts also, and it is easy to communicate this different analysis with your stakeholders. You can use it for continuous monitoring as well. Go back to the previous slide. Yeah, and you can actually use it for continuous monitoring, impact assessment, and then you can integrate your financial utilization also, like you are spending some amount in different activities in different levels, so that also you can integrate with this particular solution. And also it is very useful solution to showcase your various activities, what kind of efforts you are taking in the field. So you can create various kind of dashboards or web application, and you can show it to your stakeholders. Yeah, next. One of the important application for in CSR is you can collect various type of data from the field. So you need to collect baseline data before starting the activity. What kind of activity you need to know, what is the requirement, how many people are there within that area, what kind of people are living, their population, their education, what kind of resources they are currently having. So all that kind of data you need to collect from the field. So we have this mobile application which are very easy to use. You can create these different types of questionnaire, and you can deploy it through the mobile. It works in offline mode as well, so you don't need to be in the network when you are collecting the data. And all this data will be stored on a mobile, and once you get into the network, it will be uploaded on the server. So all this various analysis or data collection you can do, and it can create automatically the reports also, like various graphs, how many people's data has been collected, what kind of resources they are having. So it will summarize the entire data collection as well. And different types of data, like for example text data, photographs, videos, audios. So all this data can be captured through using this mobile application. And this same application can be used at different levels, like as I mentioned, for baseline surveys before doing activities. During the activities, monitoring your progress, you can actually do like how many people have actually got the benefits of your activities, currently how the progress is being done in those projects. So that kind of data collection you can do using this, and further it will be integrated with your dashboards also. So as soon as you start collecting the data, it will be generating the automated reports as well, and that same reports you can actually share with your entire stakeholder. Next. You can use this solution for planning your plantation also. So using this solution, you can analyze what kind of soil is there, what is the topography, how is the slope in that area, what is the land use in that area, and depending on the state of that particular area, you can actually select different spaces which are suitable for that area. So site suitability analysis also you can do, and you can actually use this to showcase your stakeholders also, the local communities who are actually staying over there. So you can show the different types of maps or the satellite images also to them to show, okay, this is the current situation and we are planning to do plantation in this area. So you can ask them what kind of plants they want to plant in that area, what should be the structure of plantation. So that kind of interactive sessions you can carry with your communities in the field. And further, as I have mentioned, you can actually do various kind of monitoring also during the project, as well as impact assessment after the project as well. So regularly you can collect the data like how many plants has been planted, what is the current condition in that plant, how many plants have survived. So that kind of analysis. And further you can also do analysis after a few years, how many plants have survived in that area. So if you see into the satellite images, you can use that as a proof also, like after doing this plantation, these many plants has been survived, and so much of vegetation has been grown back into that area. So this kind of different activities you can do using the GIS. You can use this solution for mapping the roads also. So in case you need to build roads in those villages, so how the current situation is there, how many roads are there, how many community members are staying in that area. And you can also see how is the topography. If you construct a particular road, how much will be the effect into that particular local, how many areas you need to excavate. So that kind of analysis you can do using this particular solution. And as I mentioned, you can show it to your stakeholders also, so they will actually realize before starting the activity how this road will be constructed, how many communities or household will be connected from this particular road, and they can actually give you suggestion, okay, we want to focus or we want this particular road more than the other road, so we can accordingly give importance to constructing this road. And again, like the continuous monitoring of this project also you can do. So before construction, after construction, how many households got benefit because of this particular road construction activities, you can easily identify. You can use this for actually environmental and restoration also, like before your activity, when you are planning to do some environmental restoration in a particular area, which are those area, how much degradation has happened into that area, what kind of activities are going on in this particular area. So that kind of analysis you can do, and you can actually talk to the people also to understand what caused those kind of effect into that area, and what kind of different activities has to be done into that area for the restoration. It may be like improving the water availability in that area so the vegetation can grow. So that kind of analysis you can do easily using this. And again, like continuous monitoring, how the your restoration is going on before the activity, how was the condition, how much land was degraded, how much vegetation or different biodiversity species were there, and after the restoration, how the vegetation has grown back into that area, what kind of water level has grown in that area. So that kind of analysis you can use it. Next. And you can actually use this solution for effective communication. So because you are doing a lot of activities in the field, CSR activities, but you need to convey this different activities to different stakeholders, maybe the local communities for which you are working, or for showing it to the government or local authorities also, that these are the activities we are doing. So you can create the entire database for that. When you are collecting the data, it will be stored into your server. You have the different baseline data sets, you have the satellite images. So all this data you can compile together and put into your server. Along with that, you can actually conduct different types of interviews also, and those interviews in the form of videos or their textual interviews, that also you can put into a single dashboard or a story map, which will be easily available to all the stakeholders or your audience. So basically you are putting all these efforts in a single web page, and all this will be available as a link. So you can share this link with your stakeholders. They can directly go to the website and see the entire effect. And you can use the same the database for different purposes, like you can put it into your own website, you can use it for putting it to your CSR, your LinkedIn also. So you can use the same creative storyboard or dashboard in different ways. Yeah, this is one of the example of storyboard, how you can use this RGIS story map. So you can see that the way they have carried this. So they identified the need in the field using the GIS, and then this is especially done for the Uganda region. So they understood the need of this particular activity in the field, how many people will get affected because of this activity. They actually find out the need, what is the need, what kind of activities has to be done, and how many people get affected. So you can see the entire, and they have put the photographs or the visual infographics also, so it is very easy to convey it to the audience. You can see these kind of graphs or the maps you can create. So before the activities, after the activities, how many local got the benefit of this. So this kind of comparative analytics also you can do. So you can do the vulnerability assessment also, like how many people are there, what kind of vulnerability is there, and what kind of activities are needed to be done in that area. So that kind of analytics you can do. Yeah, this is the different infographics or the photographs. You can also put the videos as well. So you can actually showcase your different activities, your different efforts you are taking for the CSR. You can go down further. And different kind of GIS analytics again, like how much is the reach of your activity, how many households are getting benefits from this particular activity. So this entire storyboard or the story map you can create. So it is very easy to communicate your efforts and what kind of efforts or the activities you are doing in this area. And as you can see, this is like a single link. This is a link which is available from the RGIS. You can share this link. You can actually put some restrictions also in case you don't want to put it into the public. You can have the authorization for that, user ID and password, and only those people who are having the access, they can visualize. So that kind of restricted access also you can provide using these story maps.
I would like to thank our guest speaker for today, Mr. Susanta Maharana, for joining us. His thoughts on how he used GIS at his organization were very insightful. I would also like to thank
Thank you.
Yogesh and Rohit for delivering a very informative webinar. I'm confident that this was helpful to our audience as well. I would also like to thank the audience for taking their time out and joining us for this session. So please do keep an eye out for our upcoming webinars. So you can follow us on our social media for the same. Thank you once again for joining us today. See you at the next session.